I'm Steve Cross. I kind of wear two different hats. I'm the part-time technical director for the Asphalt Recycling and Reclaiming Association that John told you about, and then I'm also a professor at Oklahoma State University. What I'm really going to tell you about, if you really came in to see exactly what's best practices, I don't have time to go over that. I'm going to give you what resources we have out there that will help you, that will lead you to what we think is best practices. But I'm going to skip through some of these early slides because John went over a lot of this for me. But with the Asphalt Recycling and Reclaiming Association, that's our webpage. We cover cold planing, hot in place recycling, two forms of cold recycling, cold in place and cold central plant, and full depth reclamation. So, you know, why are we here and where do we fit into this? This has always been kind of interesting as to where do we fit into pavement preservation and where we don't. So, according to FHWA in a document we found, pavement preservation covers minor rehabilitation, preventative maintenance, and routine maintenance. So, cold planing is used on everything, so it covers everything. Hot in place can be a corrective maintenance, or it can be a preventative or a minor rehabilitation. You put a structural overlay on it. You put a decent overlay. You're out of pavement preservation into another genre, I guess is the word to say. Cold recycling kind of falls into the same thing. And in full depth reclamation, no, that's not a preservation technique. Just kind of a little background as to why we're here, et cetera. We've all seen this. This is a deterioration curve with time. And, you know, pavement preservation techniques are typically done to preserve an existing pavement that's in good place. John told you that when you get in hot in place recycling, again, depth is 1 to 2 inches. So when I talk, people ask me about project selection, let's just keep in mind with hot in place, I'm going down 1 to 2 inches. I can treat distress in the top 1 to 2 inches. When I drop into my cold recycling, the typical cold in place recycling depth is 3 to 4 inches. So I can treat the depth, the distress is there. When I match cold in place with cold central plant, we've gone down 6 and 7 and 8 inches before. And then when you're at the end of the pavement's life and you're looking at rebuilding it or hauling it off, you've already paid for the material. How about some full depth reclamation and turn that thing into a stabilized base? So that's one of the things I always tell people to keep in mind. It's hard for us to fix what we can't reach. And so these things go different depths and reach different things. Real quick, I'm going to go through this real quick and get to the heart of the matter and be sure I leave plenty of time for our last speaker. But cold planing's used a little bit on everything. Surface or grade preparations can be used as a temporary riding surface. It's used to improve ride quality. We go to micromilling, which is a pretty hot topic right now. You can use micromilling for a permanent driving surface or to improve the ride. There's just basically a whole lot more teeth on a micromilling drum than a regular drum. Hot in place recycling, just going to give you my summary slide, then I'm going to kick over that. But we're going to use heat to soften the existing asphalt, mill it or scarify it, add a rejuvenating agent. Some processes we can add additives or add mixture if desired, and we relay and compact the pavement in one continuous process. So bear with me, you've heard this. There's surface recycling, surface remixing, surface repaving. Okay? Cold recycling, the one that's getting a tremendous amount of interest right now is cold central plant. And if you missed, Brian Diefendorfer gave a talk in here earlier and said that the state of Virginia has enough RAP that they can pave a 12-foot wide, 6-inch deep cold central plant road from Charlottesville, Virginia to Salt Lake City. Okay? So there is a tremendous amount of RAP out there, and cold central plant recycling is a really good way to utilize this and turn it into a usable product. And cold in place is basically the same process, except I'm getting the millings in place rather than from a central location where it's already been hauled off to. So, like I said, it's a viable alternative when you have stockpiles of high quality RAP. Now, if you've got a pile that's got busted concrete and this and that and whatnot in there, that's probably not what you want to use. But if you have high quality RAP, cold central plant is a very viable process. And there are instances where you simply can't get in place recycle it. You can haul the material off to a location, recycle it, bring it back. The nice thing about it, you can use it immediately. Depending on the formulation of the emulsion you can use, you can turn it into a stockpile mix. In my state, Oklahoma, built a lot of roads without shoulders, and they're getting onto us for that. So we're taking some small piles of wrap here, there, and yonder throughout the state, bringing in a unit, making a cold mix for them, and they're using it for shoulder widening on some of these low volume roads. Cold central plant recycling. I'm going to take a distressed pavement. I'm going to run a milling machine over it, and I'm going to put down a recycled layer. If I've got good aggregate base down there and a shallow depth, I can take all of it. I do want to be careful about getting into too much uncoated material. That causes problems with the mix design and emulsion dosing. If you're not real sure what's underneath there, it's not a bad idea to try to leave about 1 inch of pavement under there. That milling machine is heavy, and it's going to pull the rest of the equipment. We don't want that breaking through. Types of different trains. Up at the top, there's the more conventional train or the full unit train. It's got a full width milling machine. It's pulling another trailer. It's got a screening unit, so I can screen the oversize. I can recrush it, drops it into a pug mill. I can add my agent based on the weight of the material, and then drop it into a paver and place it. Down, I guess here, is a single unit machine, and what we do on that one is all the mixing and the cutting is done in a single it's done in the cutting chamber. So in the cutting chamber, I'm going to add water for compaction, and I'm going to add my stabilizing agent. And then you can attach a screed to the back of it like this one, or you can dump it into a paver hopper and do it either way. And we don't see too much of the 2-unit trains anymore, but that's a milling machine and an old Midland mixed paver. We still see a few of those, but not that much. By far the most popular these days. The full trains are very popular out west. We see more of those. We see a lot of the single unit trains back east. They'll both do, either one will do emulsion or foam. There's sometimes a thought that one does emulsion, one does foam. It's easy to set them up to do either one. As far as placement and compaction, density is important on this stuff. It is a cold process. I'm not going to, it's not hot mix. I'm not going to get it compacted to hot mix voids, okay? But that doesn't seem to affect the performance. But I do want as much density as I can get out of this, so I want to use heavy rollers, okay? Full depth reclamation, although not pavement preservation, they pay my bill too, so so I'm going to come in and I'm going to take a pavement that's reached the end of its life, and I'm going to stabilize it. I'm going to turn that asphalt and aggregate base and maybe some of the subgrade, and I'm going to stabilize it in place, turn it into a stabilized base course that I can build a new road on. With FDR, there's 4 types. We can do simple pulverization that some agencies do. If you want to do some grade control or improve it, I can add a little wrap or aggregate to it. If it's fairly clean, I can use the bituminous stabilization, foam or asphalt emulsion, and there's chemical, cement, lime, or type C fly ash. Cement's by far the most popular. It works over a wide range of materials. All right, so getting into the heart of this, we get questions as far as best practices. I hope you were able to see some of these presentations that were given earlier. Unfortunately, they were back-to-back against each other. But Dr. Chuck Schwartz talked about the NCHRP 9-51 project for trying to determine the material properties that you would use in the mechanistic design procedure. Bottom line out of that, these things perform quite well. They tend to perform like aggregate base, an asphalt base mix. Okay, they're not quite hot mix, but when you look at the thicker section you get, they behave very similar. And in Virginia on I-81, Brian Diefendorfer talked about that. I'm going to look at the presentation he did, but they put down a FDR and a cold central plant on I-81. It has 28,000 ADT and 28% trucks. It's had 10 million easels on it, no distress. No rutting, a tiny, tiny bit of rutting, no cracking, performing incredibly well. And then VDOT put 3 test sections down on the NCAT test track that had cold central. 2 of them had cold central plant, hot mix on top. The third one had a cement stabilized base under it. They've had 14 million easels put on them now. Rutting between the maximum rutting is 1/4 of an inch on one, no cracking. Okay, these things done correctly will perform. And if, like I said, if they'll perform on these high volume roads, they ought to perform on some of your lower volumes. So what's the key to getting a quality in-place recycling project? All right, well, it's kind of the FHWA's mantra. You got to pick the right selection, the right method, the right road, the right time. I mean, this is not something that you use, it's not the answer, it's an answer. It's a tool in your toolbox, and you really might want to take a look at using some of these if you're not. They can be very sustainable, very cost effective. One of the keys, if you're not used to doing these projects, is good communication and education. So ARRA's done quite a bit of stuff to try to help you out on that I'll go over. And then we want good specifications, okay? And that's been a little bit of an issue, and that's what I want to talk to you about with some of the things that are going on with the specifications. So, ARRA developed a set of guideline specifications, what we consider state of the practice. And why we did this is at the time, most specifications in use were generated by the contractors, the material suppliers, the equipment, and bless their hearts, if you use them, they're going to spec their process. I don't know that I blame them, but that's an issue, and we knew that. There's all kinds of environmental conditions, and you grab a specification that works well in Southern California, it may not work well in upstate New York. Another thing that we deal with, there are few test or performance parameters on these ARRA techniques. You're dealing with the material that's got to cure out, and so that's a little bit of an issue as well. So, what are these issues? And as John went over, there's really not that many issues as we see with the hot processes, such as hot in place. Most of the issues we see with the specifications and how do we test these things have to do with the cold processes. But all of them, the hot in place, all of these are dealing with in-place materials. So you're probably going to see a little higher variability, okay? If you've got an issue in there, it's an in-place recycling process, okay? One big deal about the cold processes that we don't see with the hot is these are all time dependent. If I'm using emulsions, it's going to take a while for them to cure out and get their full strength. Foam will cure out a little quicker, but it takes a little while too. We don't have the problem with cementitious. Everybody knows if I'm using cement, putting cement in there, I can't grab a field sample, take it back to the lab, and 2 days later compact it. But I've seen people try to do that with foam and emulsion. It does not work. The other thing is the cold processes all have water to help with compaction. And if I get out there with a nuclear gauge, I'm reading hydrocarbons. I'm reading hydrogen, I'm sorry. And there's hydrogen in the old wrap, there's hydrogen in the new asphalt, there's hydrogen in the water. You're not going to get a dry density, okay? You're going to have to work off of a wet density. We don't have this process and problem with the hot because it's dry, it's hot. So, for compaction monitoring, HIR typically uses conventional HMA procedures. Okay, I compact it as a percent of GMM, no problem. With cold in place and cold central plant, for right now, we're still recommending you set up a rolling pattern and get a target density, and you monitor that. Typically, we like to see you within plus or minus 5% of your target density, and if you're off, you got to adjust. California has been experimenting with intelligent compaction. This is a nice way to set up a rolling pattern. How do you know we followed it? Intelligent compaction is working well for that. We're not quite ready to go for everybody. There's a tremendous amount of data you have to deal with, and that's quite a burden on the contractor to handle all that. But it's improving rapidly, and this is something we'll be looking at. I hear people all the time wanting to cut cores out of hot in place in FDR. I'm sorry, out of cold in place in FDR. Well, it can take weeks to months before you can recover a full core. And I should have brought one with me, but I could show you a core from an FDR or a CIR project that's 6 months old. You can't tell the difference between it and hot mix, okay? But at first, it takes a while to gain strength, so you're not going to be able to cut cores and check density in any kind of timely pattern. For FDR, it's kind of come out of the soil stabilization where the others came down from hot mix. So FDR tends to use a field compacted proctor to monitor density, and they'll grab a field moisture content to monitor it that way. Verification of field mix properties. This is same as HMA for HIR. You can still do the same thing. It's not that big a deal. For co-recycling FDR, that sample age and temperature will have a pronounced effect on your measured mix properties. And I'm sorry, but sealing uncompacted samples in containers and then taking them to the lab doesn't help, okay? If you're going to try to do this in the field, you're probably going to have to do this on site, and you're going to have to specify a compaction delay and sample temperature. I was on a project for federal lands highways, and it was kind of an interesting one. Stuff was coming down the mountain to me. Stuff that came down in the morning, I was able to compact immediately. The stuff that they brought in the afternoon, got there at 10 o'clock at night, sealed them. I heated them up and redid them the next. I brought them up to a reasonable temperature and compacted them the next day. And just to show you what happens, we were getting 13% air voids. The ones we reheated, over 20. Dry tensile strength, it didn't really have much of an impact on it. Wet tensile strength, though, with 20% air voids, you're not going to hurt it soaking in water. So my TSR was 0.75 on the road, but if I delay it, it's 90%. Okay? And it affects my emulsion. So it doesn't match what you get in the field. You got to be very careful how you do this. There's some stuff we're working on with this. The one that I'm most excited about, this is just coming out, and this is NCHRP Project 9-62, Quality Assurance and Specifications for In-Place Recycling using Asphalt-Based Recycling. It's anticipated, but the RFP just came out this week. So it looks like it's going to go. It's going to be a 3-year, $1 million project, and this is one of the biggest things we've ever seen in in-place recycling. We're very excited about this. What they basically want to do is see if we can come up with some type of a field test that will let me know when my mix is cured enough that it's safe to open it up to traffic and when I can safe to cover it up. Okay. The other thing we hope they'll take a look at, they may not get, is some type of compaction control device, because the water in this stuff in the binder is an issue. And then they're going to develop guide specifications to go along with that. So what are you going to do in the meantime while we're waiting for this stuff? Well, ARRA has put out their guide specifications. We have 4 series, the 100, 200, 300, and 400. And the 100, we call them construction best practice guidelines. They're actually written as suggested. They're written in specification language. We don't really expect anyone to take this and adopt it, verbatim. But if you're having issues and wanting some issues on specs and want to see what do they recommend here, it's in there. We have the 200 series is project sampling and mix design guidelines. Project sampling is incredibly important. We run into issues all the time that what's down there wasn't what we thought. Ground penetrating radar works really well. But we talk about, if you can't use that, the way to get a good coring process to find out what's down there before you do this. And as John said, you need to do a mix design. And then we're working on a Series 300, which is basically for our contractors, because it's quality control. If you've got a good contractor, these are the checks he ought to be making on the process to be sure he's getting a good process. And for project selection guidelines, we're working on a tech brief for FHWA on project selection, and hopefully that'll be out early next year. And again, all of them provide user notes for more information. As far as the status, in green, what's completed. The black are not completed. We're getting real close. ARRA has a meeting next month in Auburn, and we'll finish some of these up. What I'll tell you, well, let me back up. If you want these, give me a holler. And even if they're in a draft, if they're far enough along, I can give them to you as long as you don't publish them for us. Okay? But no problem, and I'll tell you how to get a copy of these if you want them. Are these any good, or are they just ARRA contractors talking about, hey, here's what we want you to do? Well, there is a emulsion expert task force, and we were tasked with putting out a mix design for CIR with emulsion. We took our ARRA mix design. We had to reword it into AASHTO format, and it's running through AASHTO, and it's sailing through pretty good so far. So when we put these things together, they weren't just ARRA contractors, they were contractors, there were suppliers, there were some academians, and even a couple of FHWA guys looked at them. So we think for state of the practice, we think they're pretty good. All right, where can you get these? Go to our webpage, under resources, slide down, and there's a section that says guidelines. And you can download them from there. And if you're like me, and that's one too many clicks on the computer, shoot me an email and I'll get them to you as well. And my contact information will be here in just a minute. The other thing we're real proud of, we put out the basic asphalt recycling manual in the early 2000s, and we just updated it last year. So we're real proud of this document. FHWA helped us out, but it's going to give you general information If you're new to this and don't know, it's got a lot of good general background information. And we cover our 4 disciplines of cold planing, hot in place recycling, cold recycling, and full depth reclamation. And then for each one of these methods, then we have 4 chapters that deal on detailed project analysis, mixed design practices, construction, and project specifications and inspections. Again, these are available on our webpage. You can come by our booth, get hold of me, and we can tell you how to get hold of a copy. Some of the things that are in there, one of the things we get hit up, and I realize you can't see this, you can't read it, but the whole idea is we've got in there, we talk about if you want to do HIR, CIR, FDR, what distresses will it address? And we have it broken down whether it'll fix it or it'll mitigate it, because realize sometimes you do things to buy time. So we have tables for HIR. We have the same thing for cold recycling. It didn't take a table for FDR, okay? You're going to reclaim the pavement, whatever distress, unless it was a deep subgrade or drainage issue you fixed, okay? We also have one of the things that comes up with FDR is what stabilizing agent do we use. So we have a recommendation. Just realize there is a lot of overlap, and it may depend upon what you use, may depend upon what contractor you have in the area and what they're used to. As far as training, if you have some people that are going to be out and doing inspection on these processes and they're not familiar with it, the Transportation Curriculum Coordination Council, or TC3, we've developed 3 web-based courses for them on HIR, cold recycling, and FDR. These used to be hosted by NHI. They've come over to the AASHTO webpage, and I will warn you, if you go in there to download it, it looks like they're going to charge you for it. But we were able to get them to put those on for free because we developed them for them. So should not be charged at checkout. And again, there are 3. I realize I'm not going to be able to leave this on here long enough for you to write it down, but the presentation will be available. And if you're having problems with these, contact me and I'll get them. But there are 3 different web-based courses basically geared for inspectors, okay, for these 3 different processes. So, you know, they're 2590, 2509, and 2593. And these are anywhere from 2 to 4 hours, okay? And they actually wanted a lot of questions on there, you know, so it's supposed to be like a course. And I'm like, yeah, well, there's some pretty simple questions on there, so you don't have to worry about that, okay? All right, finally, a couple of other things. ARRA will be glad, and realize people can't travel. If you've got a question about one of these processes or all of these processes, let us know, and we'll come out and visit you, and we'll be glad to put on a 1-day, 2-day, whatever you want training class for you. National Highway Institute has a 2-day course on in-place recycling. It's 2-day instructor-led, and then there's a little bit of stuff they want you to do ahead of time so you're familiar with the process. It looks they've done this in several places, but it looks like it's going to be done in New Mexico in the next month or 2. So if you're with an agency, I think they've got space if you wanted to send somebody to that. It's a good class. So with that, I'm done. That's my contact information if you want to get hold of me. A lot of this information is available on the webpage as well. And I'm from the good old state of Oklahoma, so we used to be known for our tornadoes. That's a picture a friend of mine took just north of town. But we're actually the earthquake capital of the United States now. So that's our number of earthquakes, but we are an energy producing state, so it has nothing to do with fracking or deep well injection, okay? They actually finally did start shutting down some injection wells. Any questions? I'll try to answer these briefly. I'll be around the rest of the day. Come by our ARRA booth. Yes, sir. Typically what we see with cold in place, anywhere from 30 to 50% cost savings. When you get out west and you start having these really long haul distances and stuff, you start seeing the higher end. You get back east where you don't have the long haul distances, but 30% is a good number for cost savings. Yeah. FDR can run 50%.
The cold in place has a cure time of 10 days?
You know, that's one of the, it just depends on what the conditions are, you know, how hot, how windy, how humid, whether you got rain. We want you to run traffic on that thing for 2 to 3 days. That helps squeeze the moisture out. It helps us get a little bit of additional compaction. If you end up getting a little rutting on that, we recommend you do secondary compaction before you overlay it. You know, that if you ended up getting a little bit of rutting in it, you can usually hit secondary compaction as long as it's a nice hot day, and you'll can pick up 2 to 3 pounds more of additional density. But yeah, it'll take, it takes, right now we're going with a moisture content. We want it on there for at least 3 days, traffic on it. We like to see the moisture content drop down below 2 to 3%, but in some instances that's not going to happen. So we'll say if you've been 10 days and it hadn't rained in a couple of days, cover it up. We don't really want it out there uncovered being rained on all summer long. But it does, you know, FDR and CIR go down with high in-place voids, so you need to cover them up.
And,
I don't want to cut into our next speaker's time, so I appreciate it. Like I said, I'll be around and stop by our booth. Glad to answer any more questions, or shoot me an email if you want any of this information. I'll get it to you. But thank you very much.
Thanks, Steve.